My name is Matt Capone, the owner of facadesX Envelope Solutions. Quick presentation today on our new facade wall panel system. We're looking to explore the world of renovations and Overclad, and in partnership with Metalleve Wall Systems, we've created this kit of parts. facadesX is my company. And at its heart, we are manufacturers representatives for cladding and wall system manufacturers from around the world. Cladding, fiber cement, windows, wall systems, air vapor barriers, and all kinds of components that really go into the wall. And it's this kit of parts that really helped us kind of create the new facade. And so we look at each of the materials as an element, and we create a compound, which is the new facade wall panel. So everything is kind of existing as a separate system or product, but then comes together in a panel. And the backbone for that is our partner called Metalleve Wall Systems. And so here you see a small cutaway section of a mock-up where we're integrating light gauge metal framing, structural insulated sheathing, cladding, and windows to create panels that can be overclad on top of existing facades. So here we'll dig into the base, the backbone, the exoskeleton, if you will, of the panel system. And so Metalleve Wall Systems, we are a manufacturer of steel stud framed walls and floors and trusses, but basically we're buying raw materials. We're buying light gauge metal frame coils. So we're buying these steel coils, commodity basis, and our system relies on a backbone called FrameCAD. So FrameCAD actually creates these machines and the software for design, for architectural design, and for structural design and all detailing. So all of our modeling is fed into a Revit-based platform that FrameCAD offers, and then we design, we engineer, and then we output to these machines to actually be printed or created individual pieces. So here on the left, you can actually see the machine, the coil comes in, feeds into the machine, and the output of the machine are basically their C-shaped stud pieces that are already cut, drilled, punched, labeled. They have service hold, they're pre-drilled, they're completely ready for an IKEA type assembly. Every piece of panel is exact and perfect. And the goal of what we're doing here is really to sell the air in between. So if you look at the diagram of this wall panel, you see that we're trying to be as efficient as possible in the use of the light gauge metal framing. So the cost of a building is basically the aggregate of all the materials plus labor. So if you think about the number of coils that go into a structure, less coils, less money. So if you look at the diagram of this wall panel, above the window, we're creating, basically we're creating a truss system instead of having back-to-back C-channels, which would be heavier, bulkier, costlier. So the more air we can have, the more efficient we can be, the more effective we can be, the more insulation can fit into that wall, and then it's essentially all the advantages from there. So we actually fabricate wall panels that are 3 and 5/8 metal studs and 6-inch in various gauges from 16 gauge all the way up to 20 and 22 gauge. So the various details of the gauges are really about structural performance, integrity, ability to be load bearing, and capacity to hold themselves in place. So very important element of the FrameCAD backbone that we rely on is that it isn't an ICC tested assembly. And the ICC is the ultimate testing protocol for performance of materials in the building market. So having this as behind us is really important. Also, our factory, our independent factory at Metalleve, is part of the audit process and tied to the prefabrication and capabilities that you get with the FrameCAD system. So very important that we have that support and protection. So once we have that steel stud backbone, we're adding some important layers. So here we're seeing pallets of structural insulated sheathing. So this is a system called Rock On that we utilize. And this product will screw fasten directly to the steel studs. This replaces the dense glass for any non-combustible type fire-rated construction, provides an insulation layer, but is also the vehicle that the cladding attaches to. So when we're putting cladding on these walls, we don't need to attach the cladding back to the studs. The front face of these panels, which are made of magnesium oxide board, are very fire resistant, but they're also very strong for screw pull out. So if you see in the front of this image, you can see a couple screws on the side of the panels. Those are actually, those are pre-set up for window returns. So essentially we're creating the steel studs from a shop drawing, a precision fabrication drawing. That same drawing is going to the rock-on factory, and they're pre-cutting and pre-manufacturing the sheets that are going to be applied to our panels. And so if we start with a steel stud wall, we then have to overlay this essentially to match or as per the specs require. So Metalleve is a factory. We are a fabricator of the raw materials to be used on site. And so we're actually serving the Northeast out of our factory in Harvard, Mass. So we have capabilities and logistics for shipping. In this project, this is a 7-story load-bearing project with steel studs and dense glass pre-applied. This is a project that is already with windows and having the sheathing and the air vapor barrier applied. And so this is where we're heading for our crop of retrofits that we're going to detail coming up here. But the process here is really pretty straightforward to create these panels and to isolate them or create them to fit on a specific project. So I want to highlight this project. This is a current job up in Salem, Massachusetts. This is kind of your typical affordable housing project built, mid-60s. This one is 6 stories, 7 stories on the other side. So a lot of these brick housing projects, they're all rented, they're occupied. Tenants must stay in them. But you think about the number of buildings like this from 3 to 5 to 7 stories around the Northeast and around the country that really need not only some way of repositioning or improving the aesthetic, but also to essentially encapsulate and create a new energy performing, high performance skin that is being put over. And so the first step that we do on site is actually to do a 3D scan to understand the layout and the panel configurations. How much does the building lean? What can we learn about that existing structure that might be unique or create difficulties? So we start from this and an architect's drawings. Maybe we have the existing drawings to create a panel layout. What is efficient? What's effective? And we have to think about items like logistics for hoisting and rigging and building access. Is a bigger panel better? Is a smaller panel better? Lots of things play into this. So this slide is a fairly complicated wall section with all kinds of black and red and blue, but this is part of the design process with the owner and the architect to really figure out the fundamental needs of the building and how we can actually attack it. So here, basically you can see that we have a brick facade, and then you have a 6-inch cavity. One of the requirements of this project was that they're going to run all of the new fresh air and new condensate lines in this service cavity. So these will be field applied and installed before our panels come. So the task was not only to create a panel, but the task was to create an offset in that cavity of 6 inches. So in the blue layer, you can actually see those are the steel studs, and then we have the structural sheathing and the cladding. But through the process of playing with dimensions, window sizes, what is the exact, let's say, recipe that's right for this building, right for every building, lining up the windows. There's a lot in that process that really is very important to understand and basically to nail as much as possible before we arrive on site. So here you see, this is actually one of our fabrication drawings. Okay, so this is from the mock-up that we created. So we actually we created 8 panels to put out on site. You can see how All the frame CAD submittal drawings are created. They list the weights, all the dimensions, so the architect can confirm. We can confirm window rough openings. And again, this goes to the structural sheathing manufacturer, and this becomes really the basis that we start to design on and figure out our tolerances in and out of the building. Here you can see some 3D views of the mock-up. We chose a fairly, let's say, innocuous corner of the building to start with. And it was actually this early this spring that we attacked and were able to install this. And this allows the owner to understand the complete goal of the project, what we're trying to do, but also for the general contractors, for the subcontractors, for all the people involved to really understand what are the complexities, what are some things that are simple, and how do we find clash detection? How do we understand where things may or may not be in the way and create issues? Specifically, one of the items is about a brick facade and how you attach to a brick facade. This building is not unique, but it is a bit different than many others. So some walls are multiple width of load-bearing bricks. This building's actually a single veneer, actually tied to a steel structure back to the building. So here you can see a little bit of an exploded axon of some of the components here. In the red, we're utilizing a masonry lintel system to create this offset. And in this diagram, we're illustrating how we set on each lintel and how we encapsulate. And since we're cladding, since we're attaching to the wall, we're turning panels back to the building at grade so that we can create that complete envelope and not have any issues. So here we see this is the actual mock-up in place. The red and white 3M, which is very visible, is the air vapor barrier. So basically you can see the steel studs. The air vapor barrier is then gift wrapped over the panels to basically your air and watertight individual panels. And so panels are hoisted into place, set, windows are already in. And then red and white is the vapor permeable barrier. The black here you see is actually the seaming, so seam tape. So since each panel is applied independently, there's a bit of a gap. So that's a pre-planned gap. And this job, I believe it's 3/8 of an inch. And so in between each panel, we're packing insulation in between, some silicone, and then we're field applying a membrane to create the connections between the panels. So you can see on the left, that's a field panel. In the middle, you can see how we're wrapping a corner. So it was important in the mock-up to kind of illustrate some different details and understand a lot of the complexities that we're going to be dealing with here. So very important. Here we're illustrating the pull test. And so we're working with the architect, the engineer of record, where we're providing the panels, we're providing all of the structural support mechanisms, but very important that the project is actually active in assisting to help us understand what this existing building can support. How can we support? Where do we support? What is the value of the bricks, the pull tests? What do they connect back to? This is a very important thing that really does vary on a lot of projects. So important. So along with the panel, a key component here is not just to put the panel in front of the wall, but also to understand how we're creating these cavities that we discussed, right? So we're creating this space. The building code looks at this space as a fire potential, right? So NFPA 285 is a fire code, fire standard that is helping to protect commercial buildings or buildings over 40 feet. And so part of the requirement is not only to have a complete fireproof layer or primary layer, but also at openings, at panel joints, floor lines, and openings, we're actually required to compartmentalize. And so one of our partners here is a world leader in basically fireproofing and isolation for compartments. So this is a pre-compressed, essentially rock wool block by side rise that we're lining the window, wrapping four sides, the sill, the jambs, and the head. And basically every window after the panels are applied, the new window is already installed, the old window is removed. And the first step is actually to take out the sash, take out the glass. Then we're putting in the fireproofing around the perimeter, and then that window is removed. And if you can imagine, there's essentially a plywood or MDO, MDF box that goes from the interior drywall finish and mates up to the inside of the new window. So we're creating a deeper window cavity, actually creating pretty nice shelf area for tenants to use. But in essence, we're trying to be as light and delicate with a building that is completely occupied. And so, yes, the tenants will need to sort of be out of the way for a day or two as this is being done, but really considered to be a light intervention. Critical detail here, we look at how we hoist and how we rig. Jobs are different. Do we have roof access? What's up on the roof? What's happening up there? Can we, can we support? Can we roll? Very important. These projects are often having full renovations of all the mechanicals. They might be adding solar. So just in our experience, we've seen that this is an important factor to understand, what we could put up there. How big a panel can we use? How small of a panel can we use? And what is really the right mix to create the recipe to solve the project. So this is just examples of another project. Here we have some details here. We're just showing how we seam tape them together. And essentially, since we're already providing a panel with a complete waterproof assembly, airtight, watertight, after the panels are installed is when the cladding actually gets applied. As we go up to the top, you then can work your way back down to install all of the cladding systems. So fairly simple idea on a panel. And we're utilizing our kit of parts here and our partners to their best. And this is actually a detailed drawing of revisions to our panels that we're integrating into sort of a 2.0 mechanism to support. Instead of sitting the panels on lintels, we're developing a system to hang the panels, so giving us more flexibility for larger panels, for more deflection. So we're evolving. We're currently working on several projects and interested in future development and work. So any questions, comments, feel free. Now's the time.
Great. Thank you so much, Matt. If anyone has a question, if you can unmute, that would be great, but then please do mute yourself again. Thanks.
This is Lisa Hart. I'm at Syracuse Housing Authority in upstate New York. When you talk about the facade, do you modify the facade based on the geographic area where the facade's going to be used? Like if you were going to use it in Florida versus California versus upstate New York, like how do you go about that based on the geographic location of where you're going to be putting the facade on the building?
Okay, definitely a good question. I would say there are a couple factors in that I think are started above our pay grade at the core requirements of the project. So we'll talk thermally, right? So we have different climate zones. Syracuse, I imagine, is pretty cold sometimes, right? It's probably pretty hot right now, but insulation. So what are the insulation requirements? What is the code? What are the goals of the project? But also many of the funding mechanisms have different requirements for U values, for R values, for air tightness and things. And so we've developed many projects where we say, oh, okay, we're going to target an R15 for the exterior skin. And halfway through they come back and say, well, in order for us to get this grant money or to get into this program, we really need to target an R21. So the geographic is important on what the core elements are, but I think it's more about the desires and goals and needs of the project to basically solve the puzzle of the individual project.
Okay, so based on the building typography and the geographic location. So if you were applying for like a DOE grant and wanted to utilize this they might have a higher threshold of what they're looking for in terms of, or NYSERDA, of what they're trying, what you're trying to achieve than something else.
Yes, for
Okay.
sure.
And you would
Definitely.
take those factors into play when you were developing what you're going to be, the product you're going to be using.
Yes, no, that's totally true. I would say one of the big variables are the type of cladding. So it might be about, how close to the water are you near? Are you near salt water? Are there issues about wind or durability of the facade? So, a 5-story project has, fairly different, design, um, wind loading requirements than a 10 or a 12-story project. So it's the sort of core requirements of a project that are, I think, the most important. And then it's really up to, how you're solving the puzzle.
And I just have one follow-up question. Like, how do you determine the viability of the existing building? Like, do you do all the study? Is that all included in the like price or anything based on like you do all that, but is that all included in the price of the facade?
So
All
there's a
of the
baseline. There's a baseline that we're looking for quantitative analysis, right? So, to do any project, we need to know how tall it is, how wide it is, how many windows, where the windows are, and even the layout of those windows. So I think that the quantitative is really on us, to provide a full package, but it's a lot of it is really the qualitative, right? So, um, meaning, is the building going to hold up? How long is it going to hold up? Who is handling? Who's responsible for the durability of the connections to the facade? So these are items that are more, they're more to do with the architect, the owner, and the engineer record about, evaluating the condition of a particular facade, you know, conducting tests, exploring, and looking into what they're finding. We, I think we intentionally stay away from that, and that is really the piece that we want to be most careful about, that we're being sort of prescribed. I think it's a little bit like IKEA. IKEA is making all the components and all all the lines, all the pieces. And you open that box, honestly a little bit limited about when you're attaching to another structure. So we intentionally look at it like that so that all those can be understood and really so you can get it right, so there are no issues down the road.
Okay, great. Thank you so much for the info. I appreciate it.
Thank you.
Hi, this is Anna
Uh,
Leopold from Paul Castrucci Architects. Two questions. One, is there a specific window manufacturer that you work with, or can you use different providers? And the second question is this sort of prefab uh, wall like product, is this something that has been used for interior retrofits at all?
Okay, let's start with the windows. So since we are a manufacturer representative of different components, we do in fact represent a window manufacturer who does passive house style windows, from Poland. So the company we work with is called Amberline. So Amberline has triple pane high performance VECA frames that are either PVC or aluminum. They can also do both. We know Paul Castrucci is, and that the office is very detail oriented in specifications for windows and performance and things. So here we utilize I'll say a fairly typical passive house system from Europe, but we are open to others as project requirements dictate or cost or whatever. But it depends on how much of that project we're sort of piloting versus other pieces that might be swapped in and out. There's no technical need or reason why the windows have to be the same, but part of that procurement process, part of the detailing, we try to make it as simple as possible based on our kit of parts. And then the other question I forgot. What was the other question?
Great. No, thank you for answering that.
No
I
problem.
was wondering if this is I mean, this is a bit of a long shot, but is this sort of prefab wall system something that's been used or could be
Oh,
used for an interior retrofit at all?
interiors, yes. So we do a lot of interior fit outs with the raw panels. Um, so think about, just an infill or a partition wall. We do a lot of interior jobs. I would say we're not doing interior sort of outsolation or insulation. It's really just meant for commercial spaces that need panels, not so much that they're insulated or watertight or whatever. Is that what you meant, to have maybe a panel on the inside of a wall that can be air sealed or something?
Yeah, that's correct. Just for obviously, overcladding is really the best for tenant in place, but sometimes there's criteria that really prevent that from being viable.
Yeah,
I
understood.
can email you about more information. Thanks for
No,
your
that sounds great.
presentation.
That sounds great. Yeah, obviously easier, quicker on the outside, the floor, no floor interruptions. So you're just limited to what you can bring into that space and tie together. So all good. Anybody else?
I just had one question. Sorry, this is Lisa Hart again in Syracuse. How loud, like noisy, is it doing this kind of work from the outside?
Um, Good question. I would
Just
say
trying to
that,
figure out like how disruptive it would be for the residents on the inside.
um, I would say fairly minimal from our experience, because we're not really taking out the old window for very long, and we're done before that window is removed. So there's always some layer that you really are cocooning things off from. So most of the disruption would be, noise from a hoisting crew working a lift or something. But I don't think that's really going to impact the interior, the occupants on the interior very much. And actually, I think from several projects that we've worked on, they've become sort of thankful enough that the building is going to be, becoming more uh, climate controlled or more consistent, having AC and having fresh air. It becomes a sort of a reward in itself. So um, some occupant patience is valuable to get towards the end goal, I would say.
Thank you. I appreciate it.
All right, thank you very much.
Matt, it's Saul. Can you say something about the exterior finishes that are available and how that gets applied? My understanding is all the fenestration is pre-fitted, but then the exterior finish is applied on site.
Yeah, so we have in our detailing here, we're showing a fiber cement product called Ceraclad that we use on a lot of new and renovated type projects. So this is a medium density fiber cement that has its own built-in, a small built-in ventilated layer. But we have jobs where we're doing metal panels, we're doing ACM, some have corrugated panels, some have high density fiber cement. So what we're creating is really a backbone for any rainscreen system, which is here. You can see how that small cavity works. So we're flexible and open to having other products. I would generally say what we're not doing is we're not doing the EFIS style insulated type stucco walls. Everything we're doing is really based on a rain screen or a ventilated facade with fasteners. Slight difference between a lot of the EFIS or a lot of the stucco type panels. That I would say that's the big difference.
But your team applies all of that after the walls go in, the exterior panels go
Yes.
in.
Yes, absolutely. Yes.
Great. I think we have time for one more question, if anyone wants to. All right, I'll
This is
ask
Lisa
one
again.
last question.
Sorry.
Oh, go ahead,
Nope.
Lisa.
I just had a question. If would you be able to do like printing on the facade if you wanted to do some like kind of art mural or anything? Is the
Yeah, we
material
actually
you would
have
be able to?
several manufacturing partners that can create sort of custom printed, custom screen print on their materials. So reach out to me and we'll see you up in Syracuse, and I'll show you some of the panels that we can do that with.
All right,
Some of
cool. Thank
some of
you.
them are actually very inexpensive to do just with the technology they have. So love to show you.
All right, awesome.
All right, thank you, everybody.
Matt, one last question regarding the
Go for it.
insulation material. Can you just say something to what you use there and the embodied carbon involved?
Sure. So typically in the wall panel, in the steel stud, we're using a fairly typical rock wool product. And then the structural sheathing, as illustrated here from Rock On, in this was actually our first generation panels are actually utilizing EPS insulation. And so embodied carbon, not as good, and also U value, not as good. So since this, we've moved on to a 2.0 panel, which is a phenolic core. And so with the phenolic core, we're able to get up to an R22 panel in 3.5 inches. So a lot more U value benefit, and also better performing from the environmental perspective. And so we're trying to be as effective as we can in that continuous layer. There are future developments of other products that will be even more sort of carbon neutral, but at this point, we're looking at, it's still a foam product, phenolic based.
Great, thank you very much. Thank you everyone for attending, and yeah, we hope you can attend our future sessions.
Thank you. Take care.